Hi everyone, I'm Akinori Ito, Tohoku University, Japan. Today's lecture is IEICE Distinguished Lectures lecture, and the title is Human-Machine Communication Towards the First-Person AI. Today's talk is about the conversational AI, in which I call first-person AI. This is the self-introduction. My name is Akinori Ito. I'm a professor at the Department of the Communications Engineering, a Graduate School of Engineering at Tohoku University. And my current area or areas of the specialization includes the speech recognition and synthesis, and the speech and multimodal dialogue systems, voice and audio coding, audio-based language learning, and the music information processing. And today's talk is about the speech and multimodal dialogue systems. The dialogue system is a kind of typical AI system that looks very similar to a human being. And today's my talk is how can we develop the system, AI system that is close to the human being. This is an introduction. This phrase is taken from the paper written by J.C.R. Licklider. The title is Among Computer Symbiosis, written in 1960. Here, the hope is that it is not too many years, human brains and computing machines will be coupled very tightly, and that the resulting partnership will think as no human brain has ever thought and process data in a way not approached by the information handling machines we know today. And that is written in 1960. I'd like to notice that the world's first electronic computer, ENIAC, was put into operation in 1946. So this paragraph is written in just after 14 years after the first computer. It shows that from the very beginning of the computer, they are thinking or dreaming that the use of computer can enhance the intellectual behavior or activity of the human being very much. And Licklider is also famous for being the first person to create the voice recognition technology in 1952. So I like his paper very much. So I took the words from his paper, and I was very impressed that the kind of the artificial intelligence, the word artificial intelligence was not coined at that time, but people are thinking the same thing, that this kind of computing or thinking machine can be a kind of the partner of the human being. Now, we all know that we are witnessing the starting of the new era of the artificial intelligence that began with the ChatGPT and other artificial intelligence system. And there have been advances in an AI through the development of the large language models, or LLMs, and that kind of large language model is evolving to a multimodal based system models, including the vision and audio. And this kind of model shows extremely superior information processing performance, including the text understanding, machine translation, information retrieval, response generation, image recognition, understanding, image generation, speech recognition, understanding, dialogue, and synthesis. And if we move this technology forward, we will move towards the video recognition, understanding, and generation. That means if we use that system to a robot, that the robot can behave like a human. But today's content is not about what the latest AI can do, but about what is missing to create an AI that can converse naturally with humans. First, I'd like to say some words about what today's AI can do. As I mentioned earlier, the development of large language models, or LLMs, has made great strides in natural language dialogue. The right part is an example of the chat with ChatGPT. Where the user says, "It's hi, today's code, isn't it?" So the ChatGPT answered, "Yes, it definitely feels chilly today. Is it one of these crisp, something like that?" And user also says, "It's cold, but I take a walk for an hour every day, so I need to go out today too." And ChatGPT answers that the impressive daily walk is a great way to stay active, or something like that. The conversation is very natural. And when we look at this example, we feel that the natural conversation with the machine already go to the great achievement, and there are nothing to do for further improvement, but there are a lot of things to do for the natural interaction with the machine. One thing I want to point is that a current AI system has only the third-person view. This example is a conversation with the human and a robot seeing an apple. If a human says, "What is this?" The AI system can understand the image, and it will answer that it's an apple. In this case, human and AI system observe the same thing outside of their systems. How about this? In this example, human and the robot are talking about the apple, and the human says it's an apple. Do you like apples? And AI system answers, "I'm a robot, so I don't eat apples." That is true. That is true. But when a human says, "Do you like apples?" What she wants to know is not that actually the AI likes apples or not. That is a kind of topic of the chat. So she wants the robot to say say the something that is good for knowing the robot or the human each other. That is a kind of topic of the chat, not an Q&A. So in this case, AI has no purpose of its own, so it can't speak for itself. And humans often confuse intelligent-looking objects with humans. I will explain this afterward. So we expect AI a human-like reaction. So this is not a problem of the AI system, but a human problem. And humans are relational creatures. This phrase is taken from the book written by Shield and Peplow, written in 1983, The Emerging Science of Relationships. The quote is that relationships with others lie at the very core of human existence. Humans are conceived within relationships, born into relationships, and live their lives within relationships with others. That is a kind of truth about the human being. And humans expect to have some relationship with other intelligent things, including the AI system. And media equation is a very famous theory of the communication by Reeves and Nass. And the media equation means that people tend to treat media, such as computers and television, as if they were real people and social entities. And individuals often respond to media in the same way they would to real human interactions. The examples are that computers can be treated with courtesy given the personalities and even have emotions. Of course, the user knows that the computer has no emotion, but from the result of the psychological experiment, it is shown that the human beings have such an feeling that is a kind of instinct of the human being. Because the human brain is wired to respond to social cues. This is a old story. This robot is called IRIS. That is a care robot. We developed this system in the early of 2000s. That is a joint project of the other laboratories. And this is a video, so I will show the video. 紅茶をください。紅茶をお持ちしますか？お願いします。かしこまりました。紅茶をお持ちします。As you see, this robot makes a conversation with the patient and brings something such as a tea or something to drink. And when we developed this robot, someone came, some project manager came to this robot and see what this robot can do. And at first, he said to this robot, hello. At that time, we did not implement the function to answer to the greeting, so we failed to move that robot properly. That is the whole story. And the moral is that most people say greeting to the robot because the users do not know what this robot can do. So first thing we do to the robot is make a greeting and ask its name and ask what this robot can do. And that is a very important point of view. And the interesting thing is that the project manager made a greeting to the robot, even though he did not know whether this robot can answer to the greeting. He thought that this robot is a kind of humanoid robot, so it should answer to the greeting. That is a very important and interesting behavior of the human. And this is another example. This is a kind of installation called The Princess in the CD Player. And this is this looks a CD player. Actually, this is a mini personal computer. And this installation talks in a voice of an elementary school girl's voice, and listen to a user's voice using a microphone and make a conversation with the user and play and eject an CD. And this installation was exhibited at an exhibition in a museum. That is an example of the voice.
CD ちゃんです。頑張るぞ。
まだ始めないの？何この曲？
These voices are recorded in Japanese by a real elementary school girl. And the interesting observation of the user is that although it did not appear to be an intelligent object, it looks like just a CD player. But some participants expressed hope that the device would be intelligent or that it would behave like a human when addressed. That is very interesting behavior. And people think that the thing is intelligent when we communicate with the object using the speech or a language. That is a very interesting observation.
CD ちゃんです。
And as I said in the previous slide, a current AI has the third person view. And when the user says it on Apple, do you like apples? You can tell it's a robot by looking at it. And the user don't want to know if the robot like apples or not. And these types of the questions encourage the self-disclosure of the interlocutors. The self-disclosure means that disclosure of the information that the other person knows, but that the speaker don't. And mutual self-disclosure strengthens social relationships. That is called the social penetration theory. So the goal of our development is that when the user says it's an apple, do you like apples? The AI should answer like that. I can't eat apples, but it looks beautiful. It's the same color as the display on my chest. By saying this, the robot should know that the apple is red, and also the color of the robot is red. They are the same colors, and the user can see that the what robot says is true. So we want the AI system answers like that. So in this talk, I would like to propose the concept of the first-person AI. And human intelligence is egocentric. That means communication is based on the assumption that not only oneself is egocentric, but the interlocutor is also egocentric. That is natural because we only knows our perception. And we assume that the interlocutor also have only the perception of the other parties. So the speaker expects the interlocutor to act on the assumption that the other person is acting with egocentric perception. So what is the first-person AI? That is not a story of the conscious AI like AI that behaves like science fiction. And what I mean is that the facilitating communication with humans by simulating the behavior expected by the interlocutor in a dialogue. This is a list of current AI and first-person AI. And current issues with the AI is that the current AI makes no social relationship with the user, and the social relationships is not assumed. But in the first-person AI, we desire that the AI system establish social relationship with users. And the current AI does not behave in a way that defines or strengthens social relationships. But we expect the first-person AI to interact based on the social norms and foster the rapport of the user. And the current AI does not address nonverbal information relevant to a communication, but we expect the first-person AI to reinforce the communication through the nonverbal behavior. That is also called a metacommunication. And the current AI system is not necessarily real-time, but the first-person AI should be real-time. And here I'd like to say some words about the metacommunication. Metacommunication is a communication to align the communication channels that is also called the social signal processing. And when we talk with others, we make some relationship between speakers. And we inevitably have the signaling for communication channels, such as start conversation, taking turns and ending a conversation. And to do that, we need to demonstrate the understanding of spoken contents. We behave that we understand the other's words or not, and express the interest in a dialogue and a desire to talk. And this is a figure of the metacommunication. To make a smooth verbal or nonverbal communication between the intellectual object, we need to know whether the other party trying to listen or not. The interlocutor actually heard the sound or understand the speech correctly, and if the interlocutor is a robot, we need to know whether the robot can respond well. And the other aspect is that the interlocutors are interested in the story or not. Are they boring or not? Are the interlocutors capable of performing their task when we ask some task to the robot, etc. And when we are talking something with the others, we always monitor this kind of information simultaneously to the conversation and exchanging the information of linguistic information. And the concept of the metacommunication is coined by the Gregory Bateson. He says that it's a communication that provides context to a primary message. And this photo shows that the two puppies are playing. And when two animals are playing, they make some kind of signaling whether that kind of attacks or behaviors are serious or play. When two puppies are playing, they do not kill each other. They are just playing. In that case, they are sending some kind of signal. They are not serious. They are just playing. He called that kind of signaling a metacommunication. And that kind of communication is observed in a telecommunications, such as a pilot signal is sent it in the radio communication, or header information in the TCP/IP communications, or header information in a HTTP protocol. In these examples, they exchange the state of the communication path, the state of the sender and receiver, and so on. So is this the same for human communication? The answer is yes. Here, once I made a hierarchical model of the human communication. I assumed the human communication has layered structures, just like a layered model of the telecommunications. That is the OSI model from the application, presentation, session, transport, network, data link, and physics. And in the physics layer, the physical model of the human communication is the physical model of the speech production, emotion and vocalization, hearing organs, perception, and neural models. In a data link layer, the model in the human communication should be the paralanguage, paralinguistic information. In the network layer, the human communication corresponds to turn-taking. In the transport layer is the nodding, listening, repeating, and so on. And the session model includes how to start and end the conversation. And in the presentation layers is linguistic expressions, and the application layer corresponds to communication tasks. And this is a correspondence between the communication hierarchy and the metacommunication. And in the communication task layer, the metacommunication includes the strengthening relationships between speakers and intimacy through self-disclosure. In the linguistic expressions, we express the social relationship using the honorific expressions in intimacy control. And in the start and end of the conversations, we make the greetings and proxemics related to personal space. And the nodding and the listening attitude layer, we make sure you are listening to the other person. And in the turn-taking layer, we need to know when to speak, when to listen to others. And the paralanguage and the facial expressions layer, the metacommunication content is the nuance of the speech and the appropriateness of speech. And the hierarchical model of the interaction is not new things. The other researchers also proposed different kind of the hierarchical layers. This model is proposed by Reimann in 2024. That is the hierarchical model of the human-robot interaction. In the core, it has the dialogue model and modalities, robot appearance, environment, and interaction domain. There should be different kind of the hierarchical model, but we think that that kind of interaction model can be hierarchical. And communication tasks are top of this hierarchy. And there are some examples of the communication tasks, such as the medical communication skills that is effectively drew the patient's condition, awareness of the illness and its impact. The other example is teaching communication skills. And it assumes a social relationship between speakers or between the user and the system. And this is the next layer, self-disclosure and intimacy. And mutual self-disclosure means the act of disclosing the personal information each other. And the mutual self-disclosure strengthens social relationships. That is called the social penetration theory. This is a example of the mutual self-disclosure in interpersonal dialogue. This person says, have you traveled anywhere recently? And the right person answers, I recently went to Hokkaido and it was amazing. And she answered, Hokkaido looks fun. I haven't been traveled recently. And here, the second utterance, I recently went to Hokkaido and it was amazing. And the right person know this fact that the left person do not know. So this is a kind of disclosure. Similarly, I haven't been traveled recently. That is also the disclosure of the information. And in human conversations, mutual disclosure makes the interlocutors feel more friendly. So we conducted the experiment of the self-disclosure, whether the mutual self-disclosure between human and machine improves the impression, user's impression to the system or not. We conducted the dialogue experiment in 3 conditions. The first one is the system self-disclosure condition, in which only the system makes the disclosure, and the user only listens to these utterances. In the second condition, the system asks the questions, only asks the questions to a user, and the user answers that question. That is the user self-disclosure condition. The third one is the mutual self-disclosure. In this condition, we have 2 sections. One is our user self-disclosure section, where system asks a question to the user. And second one is the system self-disclosure section, in which the system says something the user didn't know. And we compared the impression to the system after these dialogues. And this is experimental results. And we asked several measures, such as the satisfaction to the system, intimacy to the system, human willingness to talk, system's willingness to talk, and the dialogue flow, a smoothness of the dialogue flow. And we observed a statistically significant difference between a system disclosure and user disclosure conditions and the mutual disclosure conditions. Especially the intimacy to the system is significantly improved by the mutual disclosure condition. This result shows that the mutual disclosure can enhance the impression to the dialogue system. The next topic is the linguistic expression. Linguistic expressions to show the social relationships between the talkers. Even if the meaning is the same, linguistic expressions can lead to the social differences. In Japanese language, we have honorifics. That means when the linguistic content is the same, we can distinguish the politeness of the words using the different honorific expressions. And even in a language without honorifics, linguistic expressions can change depending on the power relationship between speakers. This is our example. We can say, "May I borrow $1?" Or, "I'm really sorry to bother you like this, but I seem to have forgotten my wallet. I was wondering if I might borrow $1 from you just until tomorrow, that is." These two sentences say the same thing, but the attitudes are different. So the power of the interlocutor is stronger. We need to use these kind of words. That is the difference of the linguistic expressions. So we conducted the experiment whether the wording changed the impression to the system. In this experiment, we control the tone of the linguistic expressions step by step and investigate the impact of the tone changes on the impression of the dialogue system. In the first day, the system talks to the user very politely, and the expressions of the system becomes more and more casual day by day, and we gradually change the system's tone. And we analyze the user's impression to the system. And this is a result of the gradual tone control. The first day, the change condition and polite conditions use the same expressions, linguistic expressions. In the casual condition, the system makes the casual expression. The second day, the change condition gradually use the casual expression. In the third day, the change condition use the totally casual expressions. And by gradually changing the linguistic expressions from polite to casual, we could improve the impressions to the dialogue system. And this is how to start and end the conversation. It is called conversation opener and closer. In artificial systems, a conversation is often initiated by saying the specific word that is called a magic word or a wake word, such as "OK Google" or "Hey Siri." But this kind of magic word is not as natural as the human being's conversation. And greetings have a conversation starting function. But that kind of expression is depend on the situation. For example, when gathering for a meeting, making the phone calls, calling people at stores, visiting counters, and so on. So we need to use different expression in different situations. And in the case of robots, research is being done on how to approach and talk to people by Satake and et al. That is related to the proxemics estimation based on the human movement direction and the speed and so on. And proxemics is a very famous theory between the social relationships and the physical distance between two persons. And degree of closeness varies depending on the social relationships between people. And they propose the four kinds of the distances, different distances. The nearest one is the intimate distance, that is between the families or lovers. And the personal distance is around 1.2 meters. That is the distance between friendly people. The social distance is from 1.2 to 3.6 meter. And public distance is more than 7.6 meters. That is a distance between people who are not socially related. So according to this theory, we tested how close can a robot approach. We conducted an experiment in which a square robot moved close to the target person, and the person stopped at the robot at the appropriate position. And the result is that the larger the robot, the larger the appropriate distance. And the distance was approximately 1 meter to 1.4 meters. That is that coincides the social distance in the proxemics. And the distance hits the plateau when the robot's height exceeds 1.2 meters. This experiment proved that we assume the same social distance to the robot, to artificial objects. And nodding and saying to the other's words is called the back channel. That is the signals that the listener is listening to what the other person is saying. And the use of back channel is culture dependent. The Japanese speakers makes more back channel the other language speakers. So that can lead to misunderstandings. And the listener's attitude towards the speaker or the contents of the conversation is also a very important aspect. And there are possible types of the listening attitudes, such as the active, appreciative, attentive, and so on. And also, rephrasing is actions taken to ensure that the speaker conveys that they want to say. And self-repair is also a behavior often observed in the natural dialogue. It is necessary to monitor what you are saying. And other initiated repair is also that kind of rephrasing. In that case, when making the conversation, someone says a mistake, and the other one says a question or a questionable facial expressions, and the speaker knows something was wrong and says the right thing again. That is the other initiated repair. And turn taking is to take the next turn in the dialogue, and there are a lot of research about the turn taking, but it is still difficult to take turn properly for the artificial system. And we need to decide when it is okay to speak in a conversation. In turn-taking cues such as the physical quantities of speech and linguistic expressions are used, such as a linguistic expression. If the sentence terminates, that is a kind of sign that the other partner can speak. And also the prosody, such as rising or falling pitch or decreasing power, is another kind of cues of the turn-taking. Also, the gaze, looking at the other person, can be a cue that the other person can take the next turn. There are also the turn-taking in the three-person or more-person conversations, but this is a more and more difficult task, even for a human being. And when taking the turn, the timing is everything. And when it comes to back-channeling and turn-taking, so they cannot be handled by non-real-time models. The turn-taking model should be real-time. And you may need to have the separate models for real-time processes and other processes. So that kind of real-time processing is very difficult. And also, the pause between turns, that is called the switching pause, is also important information for the metacommunications. In the right example, the one person says, "How are you?" and the other person answers, "Great, and you?" And if this person is an L2 speaker, not a native speaker of English, and doing the exercise of the conversation, she can make an exercise with an artificial system. In that case, the switching pause can be longer than that observed in a human-human conversation. So in the previous work, we focus on the switching poses in the machine and human-machine interaction. We developed a spoken English conversation learning system for the Japanese people. And with this system, we can make a conversation practice using the spoken dialogue system. And we use the computer graphics characters. And when making the conversation with this system, the reply timing or switching pause of a learner should be the same as in the human-human dialogues. And in case of humans, they measure the timing of the answer with the subtle facial expressions. However, it is not easy to achieve the same control for robots or characters because this kind of system does not make that kind of subtle change of the facial expressions. So in this research, we made an attempt to approximate the timing of the human conversations. In this system, we introduced the artificial expressions. We call it the time pressure expressions to promote the speech. In this system, when this character finished saying something, it gradually becomes red from the bottom to top, which prompt the user to answer. And using that time pressure effect, the latency of the answer becomes shorter here. We could decrease the switching pause. And the decrease in the latency to the switch is greater than with the reading aloud alone. And this effect continues for 2 weeks. And next topic is the paralinguistic information and the facial expressions. And the paralinguistic information is an interpretation of the various information contained in the speech, such as the intonation, voice quality, and psychological state, such as emotions. And intonation changes along with the meaning of the sentence. And we have several aspects in spoken utterance, such as the language, paralanguage, and non-language. Here, paralanguage means a non-linguistic and impersonal information contained in the speech. And non-language information means the individuality, such as gender or personal difference of the voice. And also, facial expressions and gestures contain some kind of information about the contents. According to this kind of paralinguistic information, we developed a response generation system considering the language and prosody simultaneously. In this system, the system observed the intonation of the user's speech and generated the linguistic expression of the answer and the intonation of these words simultaneously and synthesize the speech according to the generated intonation. Here, the system's linguistic and prosodic information is derived from the user's linguistic and prosodic information. And this is a comparison result. We compared 3 models with the paired comparison test. The first one is a no-pitch control. The second one is a proposed model. The third one is the proposed model that does not use the user utterance. And this is the result. And the first line means that the proposed model is preferred by the participant of the experiment compared with the no-pitch control condition. The second one is also the proposed model that does not use the user utterance is preferred compared with the no-pitch control condition. The third one is the comparison between the proposed model and the proposed model without user utterance. In comparing these conditions, the proposed model that used the previous user utterance was preferred compared with the model that does not use the user utterance. This result means that the generation of the intonation using the previous user's utterance is effective to improve the impression of the dialogue system. This is the final summary. Towards the realization of the first-person AI, I explained some concepts and works we did. And humans tend to treat other autonomous beings the way that treat other humans. And current AI does not consider social relationship in communication, especially the metacommunication point of view. So in order to accept communication in a human-like way, AI needs to have a first-person perspective. Okay, that's it. Thank you very much.